In this video, I'm going to introduce Otto. As you can see on the screen, Otto is an enhanced event bus with an emphasis on Android support. It's an open source project provided by the awesome people over at Square, the payment card guys, and it's basically an event bus. And it's awesome, and we're going to use it. And I'm going to show you how to use it. So what is an event bus? An event bus is an object that coordinates communication between other objects. So the idea is that you can have an object that does something, like maybe the object downloads a file or listens for location changes on your device, or maybe it does something completely arbitrary. It listens to push notifications, for example, from other servers, third-party servers on the internet. And that object is responsible for kind of getting notified when something happens. And then you might have other objects that are interested in that information. So you might have a bunch of other objects that really want to know when the location changes, or when a file is downloaded, or when blah blah blah, when an event happens, when some sort of arbitrary event happens. Now an event bus is really cool because we can now take that concept where we have these objects that are receivers that receive these events, and objects that are publishers that publish these events, and we can abstract them away so that neither object has to know anything about each other. So that in that way we can add multiple receivers to the same event without having to worry about changing any of the code of the object that is responsible for producing the events. And we could also completely change the implementation of how those events are produced without having to update any of the implementation of how the events are received. So an event bus is nothing more than a way to decouple communication. If that explanation was a little abstract for you guys, I have an example application put together, and I'm going to show you guys how to bring Otto into an Android application and how to use it. So I guess not a whole lot else to say here. Let's go ahead and get started. Let me introduce you guys to this sample application that I put together. It is going to be one activity with two fragments. And it might be the easiest, it might be the most obvious if I just click on activity main's layout and I show you guys what the main layout looks like. So right here I have a fragment up here at the top that has a text view and a button. And then I have multiple of these fragments. So each one of these lines is an instantiation of a different fragment. So I have my two fragments. I have my receiver fragments down here. So these are all instantiations of receiver fragment. And then I have up here button fragment. So if I go into fragment button, for example, into his layout, you see I have his text, his edit text, and his button. And if I go into fragment receiver, you'll notice he has his text view, nothing received yet. Then as far as code goes, main activity is pretty much blank. So is button fragment. Button fragment is blank except for I did instantiate or inflate the view. I aliased out our fragment button text, our edit text, into a local field, and I set up an onClick handler for the button. And then I have my receiver fragment, which all I did here was I created the onCreateView method and aliased out his text view into a local field. You'll also notice that I have stubs for my onPause and onResume methods on both my activity main and my receiver fragment. Alright, so what is the goal here with this application? What do I want to have happen? What I want to have happen is when I type in a message here and I click send, I want that message sent to all of these fragments. However, I don't want to directly couple the receiver fragment with the button fragment. In no way do I want the receiver fragment to know about the button fragment, and in no way do I want the button fragment to know about the receiver fragment. I want it completely decoupled. That's the sort of thing, that's the sort of communication that Otto allows for. So I'm going to go ahead and let's finish up the application, I guess. It's pretty straightforward. Otto makes it pretty easy to work with. Now the first thing that we're going to do here is we're going to import Otto. We need to bring it in as a dependency to our application. So let's open up our Gradle scripts and let's open up build.gradle. Make sure we're opening up the module app version. Let's locate our dependencies block and add in a new dependency. And in this case, what I'm going to do is I'm going to go ahead and say compile, and I'm going to bring in com.squareup::auto colon 1.3.6. So that's the version I'm going to import. I am going to import it with a absolute version. Okay, so now that I've edited my dependency section, notice how Android Studio is now saying that my Gradle file has changed. So let's say sync now. What that'll do is that'll actually go out onto the internet, grab Otto, and import it into our application. Super easy, no having to go around and manually download jars and set up your class or build path and all that ugly stuff. Instead, we just type in one line of code, hit sync, and we have the library. We now have Otto available in our application. How awesome is that? So what I'm going to do now is the first thing when working with Otto that you need to do is you need to create an object. An object that will be used for basically the coordination of events. So it's going to be called our bus. So the idea is that all of our events are coordinated through the singleton object, and typically you'll have one instance of this object per application. Even though that isn't a requirement, I don't see many or really any use cases of having multiple instantiations of this object. Now this object needs to be a singleton, it needs to be globally available. So that's what we're going to do. I'm going to come over here to my package, I'm going to right click, select new, and I'm going to create a Java class. And I'm going to go ahead and create a class called event bus. Hit OK. Now the first thing I'm going to do to event bus is I'm going to make sure that nobody can instantiate it. I'm really wanting to make sure that this is a singleton, that it's very clear to anybody looking at this code that you should not instantiate this class. So I'm going to create a private constructor, which makes it so you can't instantiate it. Then what I'm going to do is I'm going to create the bus. So I'm going to say private static, then type in capital BUS, and note what I get here. I get bus from com.squareup.auto. So this is the entry point into the Otto sort of library, and sort of into the Otto sort of package. This object is kind of the entry point into it. So I'm going to say enter, which of course will create that import statement at top. I'm going to say private static bus equals new bus. So I'm just going to instantiate it. I'm not going to pass in anything else. There's no need to. The defaults are fine enough. Then I'm going to create a public static bus getBus method, which simply returns bus. So now we have this class here that has a private static instantiation of our bus and a public static accessor for the bus that we can access from any point within our application. And that is it. Otto is now A, installed, and B, for all intents and purposes, it is configured and ready to go. So how do we use it? Well, the way in which we use it is to start thinking about decoupled communication in terms of events. Events are really the key word here. So if I come back here into my activity main.xml file, you'll notice that I have 1, 2, 3, 4, 5, 6 of these fragments and one of these fragments. I want them to be able to communicate with each other. Well, if you start thinking about events as opposed to the imperative programming way, the imperative programmer in you might be saying, well, you press this button, then let's loop through all of these instantiated objects and for each one invoke a particular method and tell it what was typed into the message text box. Well, that's a very imperative sort of way to think, and it's also very brittle and very coupled, and exactly the kind of thing that we are fixing by using Otto. So instead of thinking of this problem imperatively, we can think sort of in terms of events instead. What we can say instead is, this fragment produces an event. Every time the send button is clicked, it produces an event that encapsulates the data that's required to describe that event. In this case, what was typed into the edit text. Then we can flip that around and say, for all of these fragments, or this one fragment, because it is just one fragment class, but it's been instantiated multiple times, we can say that fragment class receives that event. We can sign that fragment up to receive events of the kind that are published from this fragment. So basically that means we first need to start off with creating an event. So what is an event in terms of Otto? Well, it turns out that events map very, very conveniently to the concept of a class. So in Otto, events are classes, and you can go ahead and create your own classes, and generally speaking, what you would do is you would create basic DTOs, basic data transmission objects. So the DTOs will be nothing more than a class that has a couple fields and a constructor and some accessors. So I guess let's go ahead and start off. How would we model this event? Well, we know we need a class because we're making an event. B, let's look at the data that this event constitutes, and we see that it contains simply a text message, a string. So we just need to create a class with a string field and an accessor and a constructor for convenience. So let's go ahead and do that. Now the only question is, what do we name our event? Well, I can go ahead. I'm going to create a new class, and I don't know, message event. Uninspired name, I know, but it'll work. So I'm going to create this class, and then I'm going to create a private string message, and then I'm going to create a constructor that accepts message as a parameter, and then I'm going to create a getter for message. So really simple DTO. We have a private string message that contains the message. We have a convenient constructor that allows us to instantiate the event given a constructor parameter, and we have an accessor for acquiring that local data or that private data. And that's our event. That is all an event needs to do. It doesn't need to hook into anything, doesn't need to extend from anything, doesn't need to inherit from anything, doesn't need to declare any annotations. It just needs to exist. So now that we have our event, we can go ahead and we can publish our event now. So I'm going to go ahead and do that. I'm going to open up my button fragment. And if you recall, our button fragment is the fragment that corresponds to this layout. It has its text field, and it also has its button. So when we press this button, I want to perform an event publish. So let's jump back into our message, oh, where'd that go? It disappeared on me. Let's go ahead and open that up again. Open up our button fragment. And down here on onClick, the first thing I need to do is I need to instantiate my event. So remember, this onClick method is going to be invoked when the fragment button is pressed. So the first thing I need to do is instantiate my event. So I'm going to say message event equals new message event, and then I'm going to pass in string message into its constructor argument. And for that, I'm going to pass in text.getText.toString. So remember, text is simply the aliased out edit text from our view. All right, so that's all well and good. I have my message event. How do I make the world know about it? How do I tell, for example, our... my files are just everywhere. How do I tell that these receivers need to be receiving an event? Well, it's pretty easy. First, we need to get a reference to our bus. So I'm going to say event bus dot get bus dot post event. And that's it. In fact, we could do this on one line if we wanted to. We can go ahead and keep it like that. Pretty straightforward. All we say is, Otto, here's a message, an event, that I want you to disperse to everybody who's subscribed to that event. All right, so now that we've done that, let's jump into our receiver fragment, because now we need to say, okay, so we're publishing an event, but how do we listen to events that are published? Well, it's actually going to be a two-step process. The first step is we have to subscribe to Otto. We need to tell Otto, we are a thing, and we want to be made aware of when events happen. And to do that, we need to get a reference to our, not surprisingly, our event bus, and we need to tell it about this object. Now, in Android, generally speaking, what you want to do is what I'm about to show you guys. As far as registering and unregistering, this is the accepted pattern when working with Otto. And I'll tell you why in a second. I'm going to say event bus.getBus.register this, or whoops. Let's mix these up, or reorder these. Okay, on resume, I'm going to say eventBus.getBus.register this, and on pause, I'm going to say eventBus.getBus.unregister this. Now, why are we doing that? Well, first of all, if you recall, onResume is invoked not only when the activity is resumed, but also during activity startup. So this code is guaranteed to be ran even if our application or even if our activity was never paused. Now note that, and also notice that again we unregister when we pause, and pause is also invoked when our application or when our activity gets destroyed or stopped. So by handling on resume and on pause, it's kind of a catch-all for A, when our activity gets created, and B, when it gets destroyed. Now, the reason we're registering and unregistering on resume and on pause is because events might necessitate that we make a change to our layout. For example, in this case, we want to change our text layout. We want to change our text view and change the text of the text view to the text that we received from the event. However, that will throw an error if we try to do that when our activity is paused. So to keep things really simple, we can just opt out of all events when we're paused and then opt back into all events when we're resumed. So that's why we do it like that. Okay, so now here's the big question. So now we've done that. We have registered ourselves to Otto. The final thing we have to do is subscribe to an event. Now in this case, what we do is we have to follow a very, very particular sort of scheme here. First of all, we have to use the subscribe annotation, which comes from com square up Otto. Next up, we need to create a public method that returns void that is named anything that accepts one parameter of type event that we want to receive. That is the criteria for handling an event from Otto. We need to subscribe by providing the subscribe annotation. We need to make a public method. It needs to return nothing. It can be named whatever we want, and it needs to take a single parameter, and the parameter will be of the type of the event that we want to receive. And that's it. So now what I can do is I can say text.setText got the message event.getMessage. And that's it. Now let's go ahead and hit play and see what happens. Let's go ahead and give it a sec to build. So hopefully you guys are seeing how awesome Otto can be in decoupling communication. Okay, so now we have message. Let's go ahead and type in a message. Hello, world. And let's hit send and check that out. All of these objects receive this message without having any explicit knowledge of this particular fragment. And it's not just fragments. I mean, so that's pretty exciting. We can do that. Our communication is decoupled. I can throw in another quick example. I can open up my main activity itself and say, I always like on resume appearing before on pause. I don't know why I wrote the code like that earlier. I'm going to say eventBus.getBus.register this. And then we'll say eventBus.get, not even close. eventBus.getBus.unregister this. And then I'm going to say subscribe public void on message event. And then I can do something like toast.makeToast got message event.getMessage. Of course, context is the first parameter there, which I totally failed. Ignore me. Toast.lengthShort.show. So now you see, by using Otto, I can now listen to this event in a completely different class without having to modify any other code. So now I hit send. Now notice how I get the toast. The last thing I want to show you guys with Otto is how to create a producer. So an event producer is basically a method that will return an event to an object that was just subscribed. So what does that mean? Well, see how our receiver fragment has this subscribed name anything method? Well, imagine if I wanted a default event call to be made against this method right when it gets registered. So right when this class or object gets registered, it gets a message of message event. Now, the reason you might do this is, for example, if you want to, like I said earlier about like a location example, where you might have an object that listens to location changes, and then it publishes an event every time the location changes. Well, now imagine you have a subscriber to that event, and you want that subscriber to be made aware of the last location, the last known location of the application. without requiring that the object that's producing or sending these location events is going to send another one. So you kind of think of it like a default value sort of thing. It's really easy to do. I'm going to do it in my main activity. Basically, to make a producer, you first need to be in an object that is registered with Otto. That's incredibly important. You have to be in an object that's registered. Next up, we create another annotation, or another method that has an annotation, and in this case, the annotation is called produce. Next up, the produce method must be public. It must return the event that it produces, and it must have 0 parameters. So now I can say return new message event, default message event, produced from main activity. And that's it. So now I can hit play, give it a year or two to get its act together. Check that out. Now we see that all of those fragments are now saying got the message default, or I said got the message default message event produced from main activity. So now you see the second those things were subscribed, they got that produced message. And so that's how you can handle things like caching the last known location. So it allows you to express a very, very common use case with event buses that would usually have to be done with an if-else statement. If we're just registering, then get this object from the cache and then do blah, 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 blah. Or you could just create a message producer. All right, there's not a whole lot else to say. We will be using Otto for our asynchronous decoupled service layer starting in the next video. So if you guys want to see, or I guess just check out the next video, and I will see you then.